assuming one organization has made a decision to move towards multi-tenancy, let's look what it takes to build such an application, right? So most of the developers think that multi-tenancy is all about filtering the data at the database end, and it's right now we are storing for a single tenant, and in order to make it multi-tenant, the one and only thing that they'll have to concentrate on is to filter the queries that are coming out of the database in terms of the tenant, as well as while it gets stored, properly identify the record and put it for the tenant. I hope it was as simple as it sounds, but the very nature of multi-tenancy adds much more complexities to it, and predominantly in all the areas that we are going to talk about. So what we call as non-functional requirements is, right? So those are the requirements that are not directly translated to your business functionalities, but rather the parameters that have to be governed for the successful running of the product while it is serving, right? So these are the ones that you're looking at the screen are the major non-functional requirements, and let's see how these parameters get altered or become complex for a multi-tenant application compared to an on-premise application or a single tenant application, right? Talking about scalability. So we also saw that SaaS is all about a volume game. So you become more profitable as you keep adding more customers and as you keep adding more users to it. And the very nature of multi-tenancy means that you are having to support all these customers and all these users from a single instance running, right? Which means in an on-premise application, if you were serving 10,000 users, right now if you have at even just 10 customers, it's 10x times, right? So your product has to become scalable to a higher number of volume. So there are different levels at which you have to talk about scalability. It's not just about your web application layer, because a lot of the existing technologies make it extremely easy to scale out your web layer, right? If you're going for let's say .NET, scaling out your .NET app is as breezy as possible. You just need a load balancer in the beginning, and the technology itself has a support to be load balanced. So few parameters that you'll have to watch out for is the state maintenance, the way you whether or not if you want a sticky session, or if you want to get out of sticky session, how we are going to be storing those details, etc. But the complexity itself is just not at the web layer, assuming it's a complete web native application. There could be bottlenecks at the database, right? So you might end up the concurrent users just getting 10x times bigger. So the transactions that are going to hit your database is going to be extremely high for a point of time, and hence it's going to really hit the rooftop, and you will never be able to scale up beyond a limit. So from the beginning, you will have to think through a scale out approach for the entire layer, right? Be it your web, be it your middle layer, be it your database front, be it your backend processings, right? Every single node or block of your application, you should think about scale out options. For example, the difference between scale up and scale out would be, scale up, you're just going to increase the hardware or the resource in a single mission, whereas scale out, what you're going to do is add additional resources, right? Add additional boxes that are going to be employed to process the same work or do the same piece of work. So that's a basic difference between scale up and scale out. So in a multi-tenant application, the point I'm trying to drive is look for scale out option in all the blocks or all the nodes of the application, right? Now from performance, again, tying back to the scale, you will have to measure your performance for the different, for the increased volume now. And you should also have enough instrumentation mechanisms to look at how it's performing for each of the tenants, right? You need to have performance counters and measure performance for different transactions for each of the tenant and measure it. Now, bandwidth constraints are again one another thing that you'll have to think through if you have opened up your service layer or a middle layer for integration, let's say, right? It's not going to just get the hit from one tenant, but from all the tenants throughout, which means the bandwidth necessity is going to be extremely high. And if you're also supporting things like an offline capability, like a data sync, correct, between your offline app and your SaaS app, then your bandwidth could really be high. So these are some of the considerations that you take on the performance front also. Now availability, right now the huge, it's just not in a multi-tenant. I don't think the availability as a concept holds good for a multi-tenant, but it generally holds good for a SaaS itself, because right now you are going to take the responsibility of running and running your application 99.9% uptime and so on. So what does 99.999% mean? You have five minutes downtime maybe in a year. So that's a huge SLA that you're going to meet. So what does it take? So it means that you're going to have a huge disaster recovery a mechanism, and multiple plans, right? DR1, DR2 for failover, and you might also sometimes end up offering an offline mode, right, in case network is not available, right? Say in your application that you're in your organization, if network is not available or if they are not able to access internet, then the business should not stop, and hence you might also offer an offline mode of working. And even while upgrades, you should start thinking about rolling out upgrades without having any downtime. So all these things become critical from an availability point of view. Now security is one key aspect for the entire SaaS. Again, it's more to do with, there are few points in security which are more multi-tenant specific and few which are rather SaaS specific, right? Just not applicable to multi-tenant. Even for a single tenant application, it's applicable, right? So physical and network security, it's applicable for both multi-tenant and single tenant. So you will have to ensure that your customers are convinced about your security measures and mechanisms, whether you might have to get some certifications or comply with certain standards to be able to convince your customers. So that's number one, your physical and network security itself. Now on the role-based access, you will have to think about a very flexible model. So this is something that gets a little complicated in a multi-tenant scenario, because you're not going to specifically devise one access control for a particular tenant, keeping one tenant in mind. It should be as flexible as model so that the tenant himself can or herself can come in and define their access control policy and work with it. So the role-based access our access control mechanism needs to be thought through a little different in a multi-tenant model compared to a single tenant model. It should be as customizable as possible. We will look at it in a little detail in the coming slides. Now, data encryption, since the ISP right now owns a responsibility of keeping the data, most of the secure data has to be encrypted and kept. So that's one consideration that you will need to have while storing the data. Again, you might have to go in for different encryption mechanisms as per different tenants. The keys for different tenants could be stored differently, or the keys itself could be different, right? So these are some of the aspects that you'll have to consider from a multi-tenancy perspective. Now, integration is one key aspect when you move your application from within an organization to a central hosted, right? From a SaaS perspective, having some kind of an integration mechanism is mandatory. Now, you have to expect two ways of communication also. It could be both inbound and outbound. So your integration can happen from your on-premise to your SaaS application, and can also happen vice versa. So you might have to invoke certain web services or certain services at your on-premise end. So you'll have to take care of all those things. It's better to go in for a specific framework to be able to manage this orchestration. And it is also important that you'll have to think through the multi-tenant scenario here, right? So it's not going to be one single app going to be talking to one on-premise app. So it's one SaaS application which is going to talk to multiple organizations on-premise applications. So you will have to bring in this orchestration seamlessly and then have one layer which takes care of all these things. So that's quite important from an integration perspective. Now, extensibility, you will have to have the product quite extensible for your customers, right? You should let them extend, let's say, the information that they would want to see in a screen, they would want to capture, extend the look and feel as per the need, right? Configurability and extensibility are both related. So it's the ability for the tenant to come and define what they want in the system, and the system should act accordingly. So that's what is called organization like personalization. So we'll also look at the customization support in detail in the coming slides. Now, auditing again tied back to security. You should have a very clear auditing mechanism. It could be at every event level or at a transaction level. So whatever makes sense for your application, you should turn on. But having proper audited messages are mandatory in your SaaS application. Again, you should have the provision to audit by tenant and the have reports available by tenant. So that's more important. So these are some of the non-functional requirements that become a little complex when you go for a multi-tenant. Some are by default complex for a SaaS, and it even more add one level of complexity when it gets into a multi-tenant mode. So if you do it right from the start, if you conceptualize it from the architecture and then proceed, it will become quite easy down the line for your maintenance of your products, and you will not face bottlenecks later in your development. Okay, so how do we start building a multi-tenant SaaS application? So the first thing that you will lay together is all the plumbing layers, right? So things that are going to be cross cutting, right? So these are some of the blocks that you will anyway have, like exception management, instrumentation. Some are what you would have been doing on an on-premise itself, except that now you need to bring in this tenant context and all these things. So I'm not going to explain all of these blocks. We will look into things that are going to be a little complex and that needs a little more thought process to it. But these are general stacks that one would have on the plumbing layer. Now, by what I mean by plumbing are the basic cross-cutting components that you would find in any application, be it on-premise or a multi-tenant application. But except that, when it comes to a multi-tenant application, it needs to be driven by a tenant's context. For example, exception management. You would definitely be doing exception management or logging the exceptions and all those things in your on-premise app. But when it comes to a multi-tenancy, you should have definitely parsers specific for a tenant, right? It's just not enough if you log the exceptions. In order to troubleshoot better, you should be able to quickly come and find out for which tenant the exception has occurred and what it is. So some kind of a layer that abstracts the tenant context and handles it at the back is necessary. And that's what you should be doing at exception management. Instrumentation, again, instrumentation could be for your exceptions, it could be for your performance, it could be for your specific events that are occurring in your application. So all those things you would have definitely had in your on-premise application itself. But right now, again, from you might have to have different strategies of instrumentation for tenants, as well as your parsing, or while you view the instrumented messages, you should have the capability to fetch it by tenant and so on. Caching we will look at in detail in the coming slide. So we'll see what are the things that you need to think through differently in caching when it comes to a multi-tenant app. Now, data access management, again, from a multi-tenant scenario, you need to have a complete abstracted data access management. We'll again see why it is required to do that. Service injection and policy injections, you might be doing it in your on-premise app itself. So what's service injection? At the runtime, being able to inject or in simple terms, discover a service for a particular case and being able to plug that in. So what it allows you to achieve is extreme extensibility. Now, in a multi-tenant scenario, you should definitely have the mechanism to inject the service itself based on a tenant. So that's what is going to be important for a multi-tenant case. So having an ability, say, you have to have a very defined custom logic that you cannot do with any other way, like business rules or whatever it is. So it's one exception that you want to make, and you want to plug that service code for that particular tenant. You should be able to do that. So having a very loosely coupled services that are discovered at runtime would help you solving a lot of these problems. A policy injection gives you the ability to inject code, right? Inject code at various levels of operations of your product. It helps you in bringing this aspect-oriented programming. Like, for example, if you want to instrument calls to a particular method ABC of a service, then you should be able to plug that in for a particular tenant at a runtime. So this makes it quite the product quite loosely coupled, and you would be able to add more external services to your business functionality at runtime. So that's what policy injection is about. Again, for all of these, you can end up writing your own your own blocks, or there are also a lot of proven blocks available. Like for example, if you take Microsoft, you have enterprise library that gives you blocks like exception management, instrumentation, policy injection, and so on. So what you'll have to do is pick up a block that fits to your need, and then extend on top of it for your multi-tenant features, right? For example, you might have a parser that comes along with the block. You might have to just extend it and bring in the tenant context awareness, so that you will be able to do specific things for a tenant, be it parsing or be it logging to different destinations. One tenant goes to a file, one tenant goes to a database, and so on like that. So that's about plumbing. We will talk about caching and data access management in detail in the coming slides. Now, once you have laid down the plumbing, which is quite the basic blocks that any application would need, the next level is to bring in a Sas framework itself. So what a Sas framework is going to be components that are specifically doing things for bringing in your multi-tenancy in your application, right? So we talked about a lot of NFR. So some of these components are going to help you in getting those non-functional requirements possible, right? We will again be talking about these blocks in detail, but on a high level, these whatever you're seeing on the slide are the basic building blocks of a SaaS framework. Data connection abstraction, authentication, which handles the how you log into the system, and how is your the user identification going to happen in the system is what an authentication is about. Secure data encryption, again we saw that data encryption becomes necessary because you're going to store the data in a central location. So how that has to be handled, that's a primary responsibility of this block. Now access control list, the entire who gets to do what in the system, right? Management of that is going to be taken care by this block. Customization, so you're going to have a single code base that's going to serve multiple customers. So obviously one size doesn't fit all, so you will have to have a lot of customizations in place in order to build a multi-tenant application. So this block is going to be taking primarily the care of or customizing or configuring an instance according to a tenant's need. Query generator, again, because you have a very you're not going to open up your database to your customers. Hence, it becomes very necessary that you give a flexible query mechanism so that they fetch any data, whatever data they want to look at in the system. So query generator is one block which can help you do that. Notifications, in most of the cases, you will have to send in a lot of notifications, be it emails or FTP, files that have to be shipped to FTP, SMS, etc. So the notification is going to take care of all the outbound communications from the system perspective. Audit trails, we talked about it. So this block is going to concentrate on how do you track what's happening in the system. How do you have a history of the transactions? So that's the primary responsibility of audit trail block. Scheduling, again, most of the applications would be required to run jobs, back-end jobs. So again, scheduling has to be multi-tenant aware. So you might have to differently schedule for each of the tenant jobs. So scheduling block should concentrate, is the block which is going to take the responsibility of doing that. So that's on the Sas framework. We will get into each of these blocks in detail in the coming slide and see what what are the considerations that you should have in this from a multi-tenant scenario. The operation module, so there are two aspects to it. So your basic product, if it has to be operating in a multi-tenant scenario, in order to meet the non-functional requirements, you need certain blocks. And then if you have to operate, right, you are having to do a lot of operations backend from managing your SaaS product itself. Like for an example, you need to manage the entire tenant system, you need to manage the entire subscription packages and everything. So an operation module helps in doing all the or automating your management of your SaaS application itself, or you can more talk it about your SaaS administration modules. So some of the blocks in that category are subscription management, which helps you in defining what kind of licensing you need in the system. So you might be aware that when you go to the SaaS applications, you will end up having a lot of flexible subscription models. So you should have the support from your system to be able to define and monitor and completely manage such kind of a subscription model. So your subscription management block is should take the responsibility of doing it. So tenant management, again, it primarily deals with provisioning and deprovisioning of tenants, defining the details of the tenant, activating them, deactivating them, tying up them to the license module, and so on. Now billing is, if you want to automate it, you should definitely have a complete billing module that's responsible for looking at your license, looking at the usage of the product, and then generating the invoice. So internally it also has metering, which majorly deals with tracking what each of the tenant has performed in the system against the license that they have purchased, right? So data management utilities, these are again important because right now the DB is going to reside, or the data itself is going to reside at the provider's end, and hence you should you should not open up the database itself to your organization. So you need to have some kind of an abstracted way using which your organization users can do certain amount of activities, like taking a point in time backup, being able to export data that they want, and so on. So you need to have that one abstraction layer that talks to the database, and then that your organization users or the tenant users can interact with and do operations against the data. So that's with the data management utilities. So we will get into the details of each of the blocks that we saw. Again, I'm not covering all of these. Whatever makes sense is what we are going to, whatever makes sense and whatever needs a very deep thought process is what we're going to see. We'll start with caching. So cache, we are all aware that generally you will, to increase performance, you will store data that are going to be quite static in nature on cache. So the way, if you take any Java or .NET app, it's very simple. You put it into your, there is an application cache that's available to you. You put it into it, and you take it from it. But in a scaled out scenario, that is not going to work out, because you're going to have multiple missions reading the cache and writing back to it. So you will not have a synchronization, cache synchronization, right? So if you are storing a cache or altering a cache in mission A, mission B would be serving the next request, and it will have no clue of what has happened on mission A. So it becomes quite necessary to have a central cache for these two systems right now, correct? So that's what is, so you need to have a distributed caching in a scaled out scenario, right? From a cache perspective, it's also very important that you have a very strong cache policy. You need to come up with what are the data that you're going to cache. Are you going to have only read-only cache that's only for master data and static data that are not going to change? Are you going to go for cache, or are you also going to cache transactional data? So that's something that you need to think through right from the beginning. What are your cache expiration policies? So you might have to support a lot of cache expiration policies, like could be a trigger from your application itself, could be a time sliding expiration, as and when, like the cache has to expire maybe in 1 week or so. So you need to support a lot of expiration mechanisms. Um, so these are some, this is the first step, right? So when you go for caching, you need to come up with a cache policy. Again, depending on the volume of the tenants, you might have to choose a different caching mechanism. If let's say for a particular tenant, you know that the transactional volume is going to be too huge and it's going to be very too heavy, then it doesn't make any sense to cache the data for that particular user, for that particular tenant. So you might end up having different cache policies for different tenants as well. So that's step one. You define a cache policy, and then you need to think about the distributed scenario that we saw in the beginning, right? You need to have an out of proc cache. You cannot have a cache that resides within the memory of your application. You need to have a cache distribution or a cache synchronization in place, so that if from mission A you change a cache, then it gets reflected in mission B, which is load balanced, right? So that's something that you need to take care. You need to support a local cache. So all these things, the moment you take out a cache to a central um, or a central mechanism, then again it's going to bring in a performance overhead. So you need to have some kind of a local cache policy that gets frequently synchronized with your central cache cluster or your server. So that becomes necessary as well. So if you don't have to, the good news is you don't have to do all of these by yourself. There are uh, good products available or good blocks available that help you in doing it. For example, if you take .NET, there is a huge support for it from Windows itself. Like Windows App Fabric Cache is something that you can use, which is distributed in nature. And even if you are going to host it in, let's say, a cloud, you have a lot of distributed cache support from both Amazon as well as Azure. So look at those services and try to use them instead of building all these things by yourself, because most of it is available for uh, out of product, so out of the shelf, and you can definitely leverage those. So that's on caching. So just a quick view of how the cache itself will work. So you'll have a lot of cache servers, which is represented by a logical cache layer, and that's the logical cache layer is what your different systems will be accessing. Now that's on cache. Coming to the data architecture of a multi-tenant application, we'll talk about the considerations there, right? So we saw that having scalability support at a database is quite important for a multi-tenant product. So what that means is, if suppose you're putting in 50,000 tenants in a single database, right? I'm just picking a big number, but it's not going to, whatever you do, it's not going to perform, right? So what if you're expecting higher number of customers and higher number of users, what you should do is have a sharding principle or partitioning principle. You can go in for a horizontal partitioning, wherein you should have the ability to distribute your tenants in different servers so that the load is evenly spread. correct? You might have, if you have like 100 customers, you might have 50 customers in one database and 50 in another, so that um, performance doesn't suffer, and based on the load you will be able to distribute the transactions and other things to different servers. So that's something that you need to think through right from the beginning, because that will have a lot of impact on how you design your entire system itself. So think about a partitioning principle for your database. That's number one. Now you might also support vertical partitioning. Vertical partitioning is splitting your databases by functionality rather than by rows, right? So if you have 4 modules, and if you expect a lot of transaction for say one module, you might keep that one module's data separate in another database. So you can go in for a vertical partitioning support, or you can go in for both. So from your framework, you should be able to support both horizontal and vertical partitioning together. So you should understand the complexity it brings. Before you discover a data, you need to know for that particular tenant where the data resides, and for this particular functionality where the data resides. So together, both the functionality and tenant is going to tell you where the data would be. Because of this, you might have end up in some limitations in your implementations. For example, you cannot cross join databases just like that, right? Because you do not know where the database is going to be for that particular that functionality at runtime, because you would have configured a different server for it altogether. So you should take enough considerations while you're doing cross database queries and so on. So think of your partitioning requirement. Definitely, I would say support your database partitioning, at least by horizontal partitioning. If your database server is not going to support load balancing, for example, Oracle does support load balancing using RAC. If you go with it, of course it's quite expensive, but if you choose to go with it, some of these problems would not reside. But whereas in most of the other databases, you will have to take care of it. So that's number one. So the moment you have such a partitioning, it's implicit that you need to be able to discover the connection strings at runtime, right? So you need to have this connection string abstraction that's going to um, um, identify which connection string needs to be used for the tenant and the functionality, and using that you will try to connect to the database. Again, the other consideration is when you want a combined view. Let's say you have 2 databases with 50 tenants on each. If you want to have a combined view of data from all the 100 tenants, you might have to bring in some kind of abstraction at your application layer to combine these data and then bring it as a single face in your application. So that becomes important as well. So there are different techniques to do it. Some database servers like SQL support something called a distributed partition view, using which when you have partitioned databases, you can combine the data and bring it to your application. If it is not supported, then you need to have that kind of a facility built in your application to access the data. So that's on partitioning. Coming back to the data isolation. So what's important in a multi-tenant scenario is the framework to be able to control the isolation between tenants, right? So you're going to solely depend on the developers to write the queries, and imagine in one case if they have just missed out a condition where tenant ID equal to so and so. So it's not a good scenario. All the tenants data are going to be shared. So in order to have a very secure layer from your application, you should think of having a complete abstraction that that isolates the different tenant and brings in the security at the layer. It's a framework itself, so that it doesn't get to the developers to write this again and again. So it becomes important to adopt to some kind of a data isolation mechanism. And it should be brought in at the framework level itself. So that's on data isolation. So you need to support partitioning. You need to bring in the data isolation support at your framework itself. In a partition scenario, you will also end up having a central DB. So it's important that if you have 50 tenants data in one server and 50 in another server, if there are going to be shared data across these two tenants, you will end up having a central DB. So in your DB architecture, you will find that you have tenant transactions DB that are going to be partitioned, and you will end up having a central DB also. So the central DB majorly will hold all the master data. The metadata information itself can be on it. So that's something that you need to bring in right from the beginning. Design norms, when you go for a partition database, it's important that the IDs or the primary keys are unique across all the databases, right? For if, let's say, you have 50 tenants in one server and suddenly the load increases high, and then you want to just take out one tenant from the server and move it to other. The one and only way to do this is if your primary keys are not going to be competing with the other primary keys in the other server, right? So in order to do that, it's important that the IDs are unique across the databases, and hence go with the GUID as a primary key. Now again, this point we touched upon, you should not be directly referring to your databases, because it's going to be discovered at runtime on where the data is going to sit. So these are some of the aspects that the design norms that you need to think right from the starting. Once your partition principle is determined. So if you go for a horizontal partitioning, then these are some of the design norms that you'll have to consider from the beginning. Okay, so this is at a high level on the data architecture. So just a view of how your database would look like. So we would have a central database and then partitioned databases. So the first one is going to have, like, say, 1 to n tenants. The next one will have the next set of tenants, and so on. So this is a sample view of how your database would look like. Coming to authentication. So some of the things that can get complicated in your multi-tenant scenario is if you want a single sign-on, let's say, right? So along we have been thinking about having, if your application is on-premise, if you have a product that's on-premise, then maybe you would have had a Windows authentication or an integrated authentication or an authentication against an Active Directory. The moment you take it out and bring it to a central hosted server, then it's going to be difficult to do all these because you cannot connect to your tenant's Active Directory and authenticate against it, right? So you will be serving hundreds of tenants, and each of the tenant can have their own way of authentication. So in order to do that, you should support definitely something like a federated authentication, right? And you should go with standards such as SAML, to which is more an industry standard to do with, so that you don't have to worry about who is you don't have to really in your product write the code on who is going to authenticate using what mechanism. So you can adopt to a federation server. For example, you have ADFS server for for your data centers from Microsoft, which is more like a federations, which very well fits into a federation mechanism. Or if you're hosting it in a cloud like Azure, you again have support like access control service, which would enable you to do the multi-tenant based federated authentication. So the number one, federated authentication support becomes quite mandatory in a SaaS application. Number two, you need to think about multi-tenant scenario in federation. It's not a straightforward federation that you are going to talk from one application to one identity provider. In fact, it's going to be one to many authentications of your authentication providers from your different tenants. So you need to choose a federation server that can fit well into this need and see how you can plug in this multi-tenancy into that layer also. Number three, your applications should start supporting claims. It's not going to be breezy like you only have a login page that talks to one database and then authenticate. So you should also start supporting claim-based authentication. Claim is more like identity about the user. So adopt to standards like SAML so that it's easier for you to talk to any of the authentication mechanisms from your organization's end. So that's on authentication. Just a quick view on how authentication in a federated scenario works. Then looking at authorization, right? We also saw that having a flexible access control policy is mandatory. So what does it mean? So you need to let your tenants come and define what they want in the system, right? Assume you are doing a HR system and then you have a role called employee, you have a role called HR, but your tenant totally goes by different roles in their organization. They want, say, a role called a project manager, senior project manager, and all those roles right now should be able to be added by the tenant themselves, so that they don't come to you and then you don't have to worry about doing a lot of those things. So what should happen is you should let a very customizable access control policy to the tenants, and they should be able to first define their own roles. Your application should right now be written based on privileges rather than roles. I think in most of the on-premise apps, the general pattern is you write it against roles. If you want to do an action, you generally check if the action can be performed against a role. But that mindset has to change. You will have to look at a privilege rather than a privilege is nothing but rights, right? If you are changing a particular employer's information, then you should check for the right if that person has a right to change the employee information rather than checking if that person is a HR. So what that allows you to do is define rights, write your code against the rights, and let the roles be customized by the tenants, and the roles can be mapped to the rights by the tenants themselves. So they can pick and choose what rights to give to the roles, and once the user is mapped to the roles, then they get the privileges automatically, indirectly, and based on that, the framework should filter what the user does in the system. Now, there are different kinds of access control itself, right? So one is against the actions. One, it could be against the entities, which is like, would I be able to change or add an employee, update an employee? It could be on the field itself, right? I would be able to update an employee, but I wouldn't be able to update salary information of an employee. So it could be at an entity level, it could be at the field level, it could be at the form level. I get to see all the employee information, but I wouldn't be able to see the salary, right? It could be at the form level, and it can also be at the data level. For example, I would be able to see the employees, but only people who are reporting to me, right? I would be able to see the salary of people only who are reporting to me. So this is again possible, correct? So your access control mechanisms can define what you can do, and should also be able to define who can do what in the system and who can see what in the system, right? So that's what we call as a data scope. You should be able to define the data set against which the privilege is offered to a particular role. So these are some of the considerations that you should have while building your authorization block, right? First, give number one, you give a customizable role to the tenant, and that can be mapped to the privileges. Base your code or your entire application on top of privileges rather than roles. 4, you should have different levels of privileges at the action level, at entity level, at a field level, and even at a data level. So once you do this, then you will have a flexible access control policy that your tenants can define by themselves. Okay, so one other consideration that people usually tend to forget it when you're giving, say, reports, right? It's just not your application. You have other pieces in your system, correct? Like you have a report builder that's separate. You have a notification engine that's going to be a separate piece. In all those things, you'll have to tie back your security. So that's very important. So that's an authorization. Going to audit trials, you can adopt different kinds of audit trials, and generally it will be a mix and match. So you can track events that are happening in the system. For example, I should definitely be able to track who's logged in, who is logged out, who has created an invoice, and so on. The next level of tracking can be tracking the changes itself, right? So who did exactly what in the system should be able to be tracked. What it could get to the field level, like saying such a field was updated from this value to this value on so and so date by a person XYZ. So your audit information should be able to track the entire history. Now history itself can be tracked in 2 possible ways. One, it could be a change tracking, like the one example I told, or it could be a snapshot recording. So you always record as on a date, right? The information when it was updated, this is how it was. So you keep having a history table with all the rows just appended to it. You never do an update, or if you do an update, you also have an history table that has all that just keeps on doing an insert. So that's one way of tracking history. So you need to come up with your principle of tracking history and adopt to one. It's possible that for few cases you go with a snapshot, and for few cases you go with the change tracking mechanism, right? So that's important. You come up with an auditing mechanism and you start tracking it. It could also be configured at a tenant level, because you're going to end up having a huge data. So if you think that for a particular tenant you have an SLA to track against the changes, then it's possible that you turn it on only for that particular tenant. So that's on audit trail. So data security, again, while you're storing sensitive fields on the database, there should be enough care on encrypting it. Now, on encryption, things that you need to consider are the keys for encryption, right? So you should have a proper mechanism of preserving the keys. It should be it's very important that you store the keys, and it shouldn't be available in a loose manner. At least you should go for a dual uh, storage so that it's not available just from one place. And you might also end up having different keys for different tenants, so you should adopt to uh, key storage or a key management for a particular tenant itself. Now you will end up in performance, you definitely end up in certain performance overheads because of this. You might have to so it's not advisable that you encrypt a lot of data. In fact, you should definitely weigh whether performance is important, or definitely if an encryption is important, then go for it for the particular columns. That's on data security. On customization, so this is one very important aspect that you have to consider in a multi-tenant scenario, right? So you have one code base that's going to serve multiple customers. So customizations, you can think of customization at different levels. You can have it at a view level where you just do away with, say, a logo change or a theme change. It could get complex to, say, tenants can decide whether they want to view 5 fields in a form, or they just want 4 fields in a form. They might also be able to change what are the forms that are mandatory, what are the field texts for those forms, and so on. So a view customization deals with all of these, and you should support that. Data customization allows the tenants to go and configure what they want to capture in the system. For example, an employee, you might have defined an employee to have 10 attributes. So it's quite natural that your tenants would come and ask for 5 more fields. So you should allow them the capability to add more fields to the data that you are capturing. And you should support the complete life cycle, right? They should be able to add, you should be able to report back that data, be it reports, be it services that you are offering to integrate. So at all the points you should ensure that this customization is properly reflected. Again, reports can be customized per tenant, so that's one key a feature that you will encounter. So they should support it. Business rules and workflows, again, these are quite mandatory to support, because the moment you go for a single code base, definitely there will be few scenarios where the business logic is going to be different across two different tenants. So you should support the complete business rules customization for a tenant. So you should, while you have a developer level business rule written, you should have an editor support given to the tenant so they can come in and say what they want to do in the system. Again, similar is the case with workflow. So these are the primary areas you will have to definitely support customization. So, yeah. So this is just a sample of how you can extend the data. So as you can see, you're adding a field called area code to an entity. So again, you should support most of the data types. A data type could be an integer or a varchar, or even it could be another pickup list. So you should be able to do all those customizations in your data that are captured. This is a sample of business rule configuration. Okay. Yeah, I think we covered that. Security, encryption. Coming back to notifications, so you will definitely have a need in your system to send out notifications like emails, files, and so on. So you should, your notification engine should support multiple kinds of notifications, could be email, could be FTP, sometimes you even need an SMS support and so on. B, it should support batch processing. Design your notification system to allow batch processing, so you are definitely going to end up uh, uh, because that's going to be process intensive, right? So in order, if you have to send 100 notifications at a shot, then you are slowing down your web application. So what you need to think about a back-end job that's going to run that. So think of a batch processing mechanism, and then definitely you need to support multiple notification templates for different tenants. The content for one tenant is never going to be the same as for the other tenant, so you should support multiple templates, be it emails or SMS or whatever. You should be able to support different templates for different tenants, right? So these are the three things: support different templates for different tenants, support batch processing, have a handler to support multiple kinds of notifications so that you will be able to plug in notifications quickly later. So that's our notification. Subscription. Now we have covered a lot of things on the SaaS framework. So coming to the operational modules, subscription management is one important area that you will have to look at. See, this allows you to say what each of the tenant is purchasing, correct? So you might have a model based on features. You'll say these are my 6 modules that I'm offering, and these are the say 50 features I'm offering, and you should be able to pick and choose what features are going to be purchased by your tenant. And then your licensing model should be internally tied up to your security system. We saw a privilege-based system, right? So your license model will also be one of the inputs to your security or your privilege-based system, so that whatever the user does is validated against his role as well as the license, right? The privilege is an intersection of the privileges by roles and the privileges by what the tenant has purchased, right? So your tenant could purchase just the features, or it could even be usage based subscriptions. Like if you are selling a survey software, you can totally sell, like say, blocks of surveys to be created. For example, it could be 100, or it could be one increment. You can have, you just they can send as many surveys as possible, and then you bill them based on how much ever service they has been sent. So number one, you can have a feature based subscription model. Second, you can have an usage based subscription model. You can create pre-built packages, like you can have an enterprise package, an ultimate package that encompasses all these features and usage, and so that it's easy to for you to manage, as well as for your tenants to come and subscribe to it. Or you could completely open it up, and each of the tenants can have a customized packages for them. And you should tie back your licensing module to your privileges. So that's on subscription. Your subscription again should be an input to your metering. Whatever usage has been defined for the tenant has to be metered as well. So your metering system should take this input and start metering and raise alerts if your usage levels have been overshot, and so on. For billing, I think there are a lot of external billing providers like Vindicia and so on. You can think of choosing some billing services like that and try to integrate with that as well. This is a sample page on how you might configure a package. So you can see the modules, features here. Usages are not listed here, but you can also come up with usage-based packages. That's on subscription. Coming back to tenant management. So there are two different activities that are primarily important, right? When you manage tenants, capture the details of tenants, have a mechanism to provision tenants, because the moment a tenant comes in, there are a lot of jobs that needs to be run, correct? Be it the default scripts for the tenant, be it creating um, uh, different folders for the tenant and so on. So the moment you bring in a tenant, there should be automatic jobs that you should be able to configure for the tenant. So that has to be addressed in the framework. And deprovisioning of the tenant, right? So once a tenant is deprovisioning, automatic jobs according to the SLA. If you have to wipe out, take a backup of the database and then keep it in a place, all those jobs have to be triggered when you deactivate a tenant. So these two processes have to be thought through in tenant management. Data management utilities. So we saw that your tenants can no longer work on the databases directly. So you will have to give some kind of an utility in between so that they can do some basic operations like point on time backup. They would be able to take. They should be able to restore back at a point of time data. They should be able to export data, import data, and so on. So these are some of the features that you might uh, offer to your tenants, and you can in fact charge for these services as well. So that's the major features on SaaS framework and the operation modules. So I'm just going back to the, so these are the blocks that we talked about: plumbing, SaaS framework. These are the different blocks, and these are the different blocks on the operational modules. So if you have any questions, please feel free to ask. Yeah, we have few questions. How can a SaaS-based product adopt a different implementation for different customers? I think we saw that in the customization feature, right? So in a typical SaaS product, you will provide different levels of customization, one at a view level, one at a data level. A tenant should be able to come and define or extend what data has to be captured and reported back to him, and definitely at a report level, and can also be at a business rules level and a workflow level, right? Business rules, generally you would say, if these are the conditions, then this is the step that has to happen. So you should let the tenants to come and define it. So once you give these capabilities, it's quite possible that 90% of their needs would definitely be addressed by business rules and workflow itself. But apart from it, if you want to have hookups, we also saw the capabilities in service injection and policy injection, so on, where you will be able to specifically inject code for the particular tenant. So these are the different ways by which you can tackle customizations for different customers. When you say my customer count is low, what number is low?
Yeah, I think that's a very, as you mentioned, it depends on a lot of other factors which are very specific to the business and the product, the revenue that you are charging for the customer. But on a general note, on a very high level general note, I think the threshold could be somewhere probably around a couple of dozen of customers, because once you reach the 20 mark or so, it's going to be very difficult for you to keep track of all the versions. And again, this number could completely vary. I have seen customers who have been maintaining close to 150 customers purely on the maturity level 2, and it still works for them for their own business model. So yeah, to answer that question, on a broader level, probably a couple of dozen of customers could be the benchmark you can have. The comparison of maturity models, the value to customer was marked high for level 1. Shouldn't the engineering effort be also indicative of the effort of individual customization for each customer? Yes, so as we saw the engineering effort in this case, we are not talking about the engineering effort of the product. We are talking about the engineering effort involved in migrating to a SaaS model. Now, your customer could ask for 10 other features, but that doesn't get accounted under the SaaS model. Right? So the discussion or the context here is moving to a SaaS model, what is my engineering effort? So that's the reason why the engineering effort is low, whereas compared to your advantage-wise, it's still there because you can do the specific customizations for the customer.
How much speed gets slowed when you encrypt data? Data should be encrypted till what level? See, again, of course, there is a performance overhead when you go for encryption, right? And it gets a little more complicated when you're using this column in reports and so on, because you'll never be able to directly get the data out. So, I mean, in my experience, I haven't seen a case where you end up encrypting a huge load of columns, right? It would be, what are the columns you will encrypt if you really look into it? So like say a credit card number, password, SSNs. So these are the most sensitive, salary maybe, right? These are some of the sensitive information that you will have to encrypt. It's not necessary that you encrypt a whole bunch of columns. Just go for ones that are mandatory and again tied back to your compliance requirements, and the rest you can have other security measures to mitigate, right? Have a high privileged user alone access the database, never give the access to anyone else. Don't open it up for your tenants, and there are other processes by which you can mitigate security risks. But from encryption, just encrypt data that are mandatory to do so. Yeah, what about the multilingual functionality? That's again a good question. Again, I think we haven't talked about multilingual functionality from a multi-tenancy perspective. We saw in a view customization that sometimes you would be required to give most of the cases I would say that you should let the customers or the tenants configure what field text they would see again in the form and what are the static messages that they would like to see. Now, all of these things you will have to tie back to your resources or the localization requirements, right? So you might end up having locales a text or localization text for each of the tenant, right? So your localization itself, whatever comes inbuilt, has to be a little extended to have the tenant context in place or the tenant awareness. So that's important. Can one have multiple, for a multi-tenant mode, how can one have multiple authentication provider for different tenants? In .NET, does ACS and federated identity handle this for us automatically? Or does this involve creating identity STS and federation STS? See, for handling a federated scenario, adopting to a federation server is required. Federation server like ADFS, right? Now, ADFS supports certain kinds of STS, right? If it's, and it can also talk to other ADFS and then bring in the single sign-on and so on. But if you want to go by your own way, then you'll have to really write your own custom STS and then plug into your ADFS. Similarly for ACS. Now, ACS has has a list of STS that they support, correct? It could be based on your ADFS, it could be based on your Windows Live, Google, and so all the live identities. But in case you want your own authentication mechanism, you can write your custom STS and plug it in. But as such, .NET has WIF, Windows Identity Foundation, that supports you in accessing claims and acting on top of it, but you need to definitely talk to one federation server to be able to do all the authentication seamlessly. If you are planning to write one, I would tell you it's quite complicated. In multi-tenancy, when you update patch, how you prevent the clients from getting affected? See, I think when I suspect when you see a patch, it's a issue fix. Correct. I think
The whole idea of multi-tenancy is to have the one code base being able to serve for all your customers. So now, if you are very specific that it should not spread or affect to the other customers, then I think there is a conflict there. So we really need to see why is such the case, because you are going to test it against the general use case or general scenario, right? So if it works for one customer, then it's going to work. But however, there could be a shortcut where you may probably want to have some configuration settings where through configuration you can probably have this patch work for certain customers. But that's not the ideal approach that you should take.
Yeah. What benefits or advantages do PaaS providers like Azure or Amazon provide as compared to IaaS providers? See, IaaS, you have to think it of as a hardware given to you as a service. That's all, right? You get a mission. Whatever you're going to in Amazon, whatever you're going to host it, right? You're responsible for it, right? You're supposed to maintain. If like say you're having an IaaS instance, you are supposed to maintain if your IaaS is up and running. You are supposed to maintain the health if you have a SQL server in, correct? Now, all those services also comes inbuilt in Azure. So it's a complete abstraction, right? So you write code, you put it on there, and then you don't have to worry about whether it's up and running, because they give you an SLA, and that's what you'll have to go by. So they will ensure Azure itself will ensure that if your instance is down due to some hardware failure or so, that it would span on other instance, and entire health check is available. It's automatically load balanced. So all those things you don't have to handle. You're giving it to Azure. On the other hand, you will lose out on certain control. You will have to go with a certain way of programming, and so which you don't have to follow in Amazon. So those are the trade-offs. So if you have one tenant using ADFS and other tenants using form authentication with credential, in this case, do we need a custom identity provider, or we can use ACS for this scenario? See, there are different ways you can handle this. Like in your application, you can simply get one configuration of saying whether you are going to be the identity provider or you're going to have ADFS take care of it, right? There are two ways to do it. If you don't want ADFS, you directly authenticate them. So you can actually handle it in your authentication block and don't even redirect them to ADFS. Or in ADFS, for that particular tenant, redirect them back to your own, your STS or your identity provider, right? So both are mechanisms that you can work with. The first one is more simpler, and if the login mechanism is only through a username password from your application, then it works well. But in an integrated scenario from an offline, if you want the same orchestration to happen even otherwise, right, from a service or an integration service, then go with the second where you plug in this identity provider in ADFS. Now, both can be achieved in ADFS itself. So I wouldn't say this compels you to go to ACS, but if you're hosting on Azure, definitely take a look at ACS, which will provide you the same functionality.
There's one other question on any thoughts on build versus buy for an enterprise SaaS app, similar to the G example. Do you have an ROI justification model? Yeah, the build versus buy is always going to be there, particularly for enterprises, where you're going to evaluate if it makes sense to build a new solution, or is there a solution that's already available. Well, on a general note, you do have plenty of options today with the SaaS model itself catching up. A lot of products are offered through SaaS models, so I'm not sure in terms of the specific application you're referring to, but as an option, yes, you do have the option of going for an existing SaaS software or an application instead of trying to build build something from scratch. From an ROI perspective, it's very difficult to comprehend without the numbers in place. So basically, you just have to see what's the cost of having those software. And the most important thing is it's not just the cost, but you should think that the complete ownership of the software is with the SaaS provider instead of you, where your developers, your IT people have to take care of the software. In this case, it's going to be all taken care by the SaaS provider.
Okay, so please throw some more light on primary key issues and multi-tenancy modules. I think this is more in relevance to the partitioning, right? So, assume a case that you have integer-based primary keys, correct? So you have 50 customers in server A, right? So if you have integer-based primary key, what happens is in server B, you will have the same primary key, right? If you say employee ID starts with 123, you will have one employee with the same ID 123 in server B also. Right now, if you're trying to take one tenant from server A and port him to server B, what will happen is, assume that server's employees has primary key 100, then there are all chances that the 100 primary key is taken by another tenant's employee, correct? So you no longer can port data from one system to other system. So that's the primary problem. So if you want to have the flexibility of moving, taking one data, moving it to other, and so on, then you will end up facing problems. So right from the beginning, if you go for a unique key, then this problem is solved. Okay. So do you have any idea on when SQL as your federation is likely to be released? I don't think I'm sure of the dates, but it's definitely on the roadmap, and very soon it's going to get released. To if with SQL as your federation, most of your problems on identifying which tenant has to be taken from which table or database, those problems will automatically go away, because SQL as your federation itself will give you that abstraction anyways. So I hope it gets released soon, but I don't have an idea on the exact date. Okay, so we have
yeah, I think we pretty much reached the time we had scheduled for this webinar. You can feel free to post any other questions you have, and we will try to get back to you offline. Once again, thanks everyone for taking the time to be here with us, and we will be sharing this presentation and the recording in our website soon. So you can visit to texelo.com to download the webinar content as such. So thanks everyone, and have a great day. Bye.
Thanks a lot.